With this lecture, we're going to continue our journey through ionic naming, and we're going to do polyatomic ions with this lecture. So make sure that you have that ion packet out, because we are going to be going through the polys. So just to make sure that you're writing them correctly and that you're naming them correctly. So polyatomic ionic compounds. So with these, you're going to see one or more polyatomic ions that will be used in the compound. Now, since it's ionic, you're still going to have a positive component and a negative component. So if you remember, when we look at our polyatomic compounds, most of them are negative. Actually, all of them are negative except for ammonium. So you're going to see your negatives show up a lot more, but you have to have a positive component. So that would be our type 1 and our type 2 ions. Our charges are still going to cancel just as they have with our other ionic compounds. And now this is a key thing. So star this, underline this, highlight this, whatever you need to do right now. You cannot change the subscripts on a polyatomic ion. So I'm going to show you some examples of what that looks like, but I need this to be somehow marked in your notes right now, that this is a very key component that you're going to need to make sure that you remember. We're going to be using parentheses to separate our ions and our subscripts, so that is going to help out with that, so we're not changing our ions. We're going to use type 1 and type 2 cations, so those, remember, your ones that you can find from the periodic table, like your potassium is always going to be +1, your calcium is always +2, but we're also going to see type 2, so you're going to see your iron that could be a +2 or a +3, so you're going to have to pull in those Roman numeral ones again with this, but they're not going to be indicated to you if it's type 1 or type 2, so that's where I said before, you're going to need to know the differences between them. You're going to see that with this type of naming. And last but certainly not least, we already know the importance of this, but always write out your charges above. Especially when we're doing these, it's going to help you. It's going to help you with keeping all of your information intact. All right, so our first example here is Li2SO4. Now, the reason I want you to have your ion packet out, and eventually you're not going to need it because you're going to know them so well, but it's going to help for recognizing what part of this is ionic, or what part of this is your poly and what part's not. So we know automatically that this part right here is lithium. And then SO4. If I keep all of that together, that is a polyatomic ion. That's sulfate. So, taking a look at this here, we're going to do the same thing we've done. We're going to uncross our charges. So the 2 is going to go here. Now, what's behind this is a 1. It's not a 4. The 4 tells me that I have 4 oxygens. Okay, so this is where we're saying we can't change our charges, and we're going to use parentheses to help us keep track. So this 1 is going to go here. So this is a -2 charge. This is a +1. So then we go through and we name it. Lithium. Does lithium need a Roman numeral? No. It's an alkali metal, so it's always going to be +1. So we name our cation, then we name our anion, and our anion in this situation is sulfate. And then we're done. So you're just naming the 2 components. The hardest part that you're going to have to get used to is identifying where is my polyatomic ion. What part of that is the polyatomic ion? Where do I divide out? Okay, so that's why I want you to have that ion packet, like I said. Have that close by so you can reference that for right now. All right, next one, we have Mg3PO42. So this one is already kind of divided out for you because the PO4 is in parentheses. So this means that I have 2 of these, okay? Just like I have 3 magnesiums. So take a look at your ion packet. We're going to uncross our charges here, so the 2 is going to go here. The 3 belongs that. So this is PO4. And we know that our anion comes second, so we know that charge is a -3. So what's PO4 -3? Phosphate. Alright, so now we just write out the names. Mg is magnesium. Does magnesium need a Roman numeral? Does not. It's an alkaline earth metal. Magnesium phosphate. Alright, so let's just take a look at what this would look like if we didn't use the parentheses, just so I can kind of give you an idea of why those parentheses are so important. If not, it would look like this. Mg3 PO4 2. Do we see how that can be a little bit confusing? So that number on the outside, once I add that parentheses, it then indicates to me that whatever in the parentheses is its own unit. That's why we were easily able to identify that that was phosphate. But if you're looking at PO42, not so easy. Alright, next one. KNO3. So first part is identify what your cation is. My cation in this is going to be K, which means that the rest of this, the NO3, is my anion. Now, is 3 my charge that's being uncrossed, or is 3 part of the ion? Well, 2 ways that you can look. One, do you see anything that is NO3 in your packet? And if I were to uncross this, does potassium have a +3 charge? No, it doesn't. So we can know then, we know that that 3 belongs to this NO. So what's NO3? Nitrate. Alright, so we just go ahead and name it. K is potassium. Does potassium need a Roman numeral? No, it's a alkali metal. So this is just potassium nitrate. So we're starting to see already why it's important that we know our polyatomic ions. It makes everything a lot easier. Alright, next one. First thing you got to do, identify your cation. Okay, so this looks a little bit different, right? So I could start it with the N. Well, N is nitride, which has a -3 charge. So that can't be my cation because it has a negative charge. So keep looking. What about what is underlined in purple here? NH4. That's a polyatomic ion. So what I can do is I can kind of block this off in parentheses by itself. So that's my positive. Remember that that 4 goes with the H. And then my negative here is ClO2. Do we find a ClO2 somewhere in our ion packet? You should. That's chlorite. So you name the first part. Ammonium. And then ClO2 is chlorite. Ammonium chlorite. Don't need a Roman numeral here because ammonium's always going to have a +1 charge. Chlorite has a -1, so they already canceled themselves out. All right, this one also already in parentheses for you, so it makes everything a little bit easier to identify. So first thing I have to do, identify my cation. It's right there. That's going to be titanium. Titanium. I know I kind of put those letters a little bit together there. And then my anion is already outlined for me. C2H3O2 is acetate. But can I stop here? No, because titanium requires a Roman numeral. So now I'm going to have to take a look at my charges. So I'm going to uncross my charges. The 2 goes here. There's nothing following my titanium, which means that's going to be a -1, which makes sense because acetate is C2H3O2 minus. So what charge does my titanium have? A +2, so that needs a Roman numeral of 2 here. So make sure that you know which ones require a Roman numeral and which ones do not. Alright, take a look at this one. Try this one on your own. Hit pause and come back and we will see how you did. Alright, so here's our answer. We should end up with iron 3 sulfite. So remember, iron is one of my type 2s, so it needs a Roman numeral to indicate its charge. So how do I figure out its charges? I'm going to uncross my charges. So the 2 that was here belongs to the sulfite, because sulfite is SO3 minus 2, which means that that 3 belongs to the iron. So here is our +3 charge. Alright, so now let's go the other way. We're starting out with the words and we want to write out the formula. So what do we need to do anytime that we have the words? You should be saying, write out the charges. We need to write out the charges. So if you're taking a look at your periodic table or you're looking at your ion packet, you know that calcium has a +2 charge and nitrate has a -1 charge. So what do I need to do here? You got it. We got to cross our charges. So the 1 now belongs to the calcium, the 2 belongs to the nitrate. So CaNO3 is nitrate. What do I do with that 2? Remember, I can't put it right there, right? Because if I put it right there, then it looks like NO32. So what do I do to separate it? I'm going to add those parentheses. So now I have 2 nitrates, not 32 oxygens. So let's take a look at the next one. Potassium cyanide. So if we're looking, what's my charge on potassium? +1. What's my charge on cyanide? -1. Perfect. Don't have to really do anything. If I cross my charges, they already cancel themselves out. So I'm left with KCN. So in this situation, parentheses are not necessary because we don't have any subscripts that we're trying to denote that are not included with the poly. If you were to write it like this, that is not incorrect. Okay, if it makes you feel better to always block out your polyatomic within the parentheses, go for it. This is not incorrect. All right, but if in our situation with our calcium here, if we didn't have those parentheses, that would be incorrect. So make sure that you're using them when they're required. All right, another one here. We have zinc phosphite. So my charge on zinc, I know zinc is always +2. Even though it's a transition metal, it's one that always has the same charge. Phosphite has a -3 charge. What do we do with our charges when they are not the same? You got it. We cross them. So now the 3 goes with my zinc, my 2 goes with my phosphite. So I'm left with ZN3. Phosphite is PO3. 2. Remember, we don't have 32 oxygens. Gotta add those in there. This is a 3 here, sorry. Alright, I'm going to show you another one. I want you to try this one on your own and see how you do. So go ahead and pause it, write that one down, and then start playing again once you have it finished. Alright, so here's what you should be left with, is CuClO4. That copper, it's indicated to us here that it has a +1 charge. Perchlorate, we know has a -1, so no need to cross our charges there because they already cancel each other out. And then, like I said before, if you added some parentheses here to separate out your polyatomic ion, that's fine. If you didn't add them, that's fine as well. It's kind of up to you. So your practice sheet for this is going to have all polyatomic ions, whether it's your cation or your anion or both. At least one of them will be a poly, so make sure that you have your ion packet out when you are doing those. And then also make sure that you're practicing which of my cations, my type 1 and type 2 ions, which ones need Roman numerals and which ones do not. Alright, so go ahead, give those a shot, and let me know if you need anything else.